Hey there, this is John over at MLC CAD Systems. I'm excited to share with you about what's new with SOLIDWORKS Simulation 2023. There are really some great features available that are really made just to help you become more efficient and quicker in setting up your simulations. Now this video is going to be a little bit different, that we're going to go deeper than just a demo or telling you what the new features are. But I'm going to go through some of the clicks as more of a tutorial so that you can start using some of these features in your own work. Now, with that being said, this tutorial is going to be tailored more to people that are already familiar with SOLIDWORKS simulation due to the nature of, hey, just showing the new features and the tutorial there. But there are really some great features to help out with that. So to show these features, we're going to use this model that we have up here on the screen for this sewing machine. Now, for as commonplace as a sewing machine is, it's amazing actually how complex a mechanical system it is. I'll switch over to this little animation of this model here that shows some of the inner workings of this model. All that's done for sewing there, from your gear systems, for your needle to your different motors and stuff there. So pretty complex mechanical system. Now on our SOLIDWORKS model here, we're very first going to be looking at this top presser needle bar. Now this is the foot that holds the fabric against the sewing machine, and you have your needle there. And so there's a number of mechanical components just on here. Now on this design requires that you have this spring that pushes this foot into the fabric, so it needs to be strong enough in order to hold the fabric down. However, this lever here is used to lift it up and down. So like, hey, when you're taking out the fabric there, so it needs to be, the spring needs to be stiff enough to hold it down against the fabric, but not too stiff that it's hard for the user to use this lever to bring it up. So we're going to go ahead and we're going to look at the first new feature for SOLIDWORKS Simulation 2023, which is going to be our contact penalty stiffness factor. Now, on here, we're going to simplify this analysis so it's only our handle and one of the brackets there. Now, the simulation is obviously pretty straightforward. We have a force that's going to be simulating the amount of force from the spring. There, that's fixed, but we need to evaluate, hey, the stress is in here, but then the amount of force that it takes for it to rotate. Now, in simulations, for people that have run simulations for a while, you'll know that one of the most computationally intensive parts of running a simulation is your contact interactions, parts interacting with each other, and particularly sliding contacts. Now, in this case, it's just two small parts, but we do have a sliding contact between these parts right here where they move relative to each other. Now, before this and other simulation packages, you just kind of had to deal with it. Hey, just wait for the time to solve, even if you're just doing an initial first pass analysis, that you have to wait. But new in SOLIDWORKS Simulation 2023 is this option for contact penalty stiffness factor. Now, to get to it, you right-click your top-level study and go to Properties. And then within here, there's this drop-down, or I guess this slider bar for changing the contact penalty stiffness factor. Now, basically what this is it tells a solver, hey, you can sacrifice a little bit of accuracy in your problem, accuracy in your area of contacts for much faster solve time. So you can still have accurate results, assuming you follow all the other mesh convergence and typical FEA theory aspects, but you can sacrifice some results right here, but still get the force transfer and things like that. So precise is what it's always been on up to this point, I guess in other versions, but now the slider allows you to bring it down to go down to less accurate in that area, but to increase solve time. Now, in this case, it's a pretty simple analysis of what you're doing. But when you have it on the regular precise option, this one solves in just over 4 minutes, about 4 minutes and 20 seconds. but then when you bring it down to the approximate, it brings it down by almost half, going down to about 2 minutes and 20 seconds. So this can be a great tool, hey, as you're setting up your first pass analysis, same reason you use coarse mesh to begin with, or even go to a draft quality mesh. Hey, you need to evaluate your results. You need to go through a few iterations before you run your first pass. So a great tool to be able to get to that endpoint quicker. So a cool option, pretty straightforward to use. Again, you just right-click your top-level assembly, go to Properties, and you can change it here. Obviously, one of the most important things to remember is that, hey, if you change it down just for temporarily set it up, that later if you do a final pass where you're concerned about the stress in your area of contact, you need to go back here and slide it back up. Now, one thing that's interesting, I mean, it does have 5 different options of the 1, 0.3, 0.1, and so on. In here, I really only see you using 1 or 0.01. Either you want it accurate or you want it to run as fast as possible. But those other options are there, but for the most part, you'll just use the 1 or 0.01. So, cool new tool, really, that can help save a lot of time in helping you get to your end result of setting up a problem correctly and validating those results. Alrighty, so the next enhancement we're going to talk about is that there is more control or more advanced algorithms in setting up bonded local interactions. Now, just as a reminder, hey, you have your local interactions that generally set up, hey, contact or bonded are your 2 most common ones. But up to this point, if you had faces that were kind of skewed to each other, then hey, you couldn't directly add a bonded connection. There, you have to go modify the geometry and then do it from there. So new in SOLIDWORKS 2023 is that it gives more flexibility in the bonded interactions that you can apply. So on here, I'll go to a little example here first, and we'll go back to our sewing machine. This is a simple plate. So in previous versions, we could have not added a bonded interaction between these because, hey, those faces have a large angle between them there, and so you'd have to modify the geometry. But now, there's no problem. Hey, going in here, adding your typical bonded interaction. With that, so it's added. Run the study just to show that it does actually bond those faces there, so it's acting as the one piece there. So I think one of these tools that you don't know you need it until you need it there, but a great tool that can help save some time in your setup. Not used all the time, but when you do need it, it can save some geometry modifications. To go along with this enhancement, I'll go back to the sewing machine. But right here we have this needle press assembly. So this is where the needle is put in and held into place, and you have these set screws that go through these holes to hold it in place. Now I suppress these out of this analysis, but we see, hey, this hole in this face is like a set screw just to keep it in place. So it'd be a fair assumption to add those as bonded. The set screw is supposed to keep it in place. But it's kind of an odd angle, a hole to a sideways face there. Previous versions, we wouldn't have been able to add that contact, but now I can go in and add that local interaction, bonded. I'll bond this to that, then add another bonded interaction to this face to that face. And then we can see, hey, we can run this study real quick here just to show that we do get those bonded interactions in there. So hey, it bonds those together. So a cool tool to be able to use in different circumstances in your analysis. Alrighty, so the next new enhancement in 2023 is a few ones that will be combined here. So the first one is that there's a new drop-down menu on your Diagnostic Tools, this Diagnostic Tools ones. Now, all these commands have been available in SOLIDWORKS Simulation in previous versions, but they were kind of hard to find in all these right-click menus. Kind of a user-friendliness aspect there. I would teach about most of these items in the simulation classes that I teach, but often people either wouldn't use them or wouldn't remember them because they were harder to find. So just combine some tools here to be able to make it quicker for your analysis. So for example, in this part here, and this is our thread take-up assembly, so it's at the top of the thread to bring it up. You have this analysis, but because of some of these complex geometries in here, you might expect, hey, some of the mesh, you need to verify that you have a good enough aspect ratio, or you have your mesh elements being close to that perfect pyramid size. And so you can quickly go in here and do, hey, your mesh quality diagnostics tool in here and look at that aspect ratio. And then quickly identify, hey, all these ones here are ones that are very skewed, so you would need to go in and refine the mesh in those areas for sure to get any sort of accurate results in that area. So it's all there in that circumstance. The other one I want to talk about is underconstrained bodies. Now the command underconstrained bodies has been available in simulation for a while, but this year they've revamped the entire thing and and really what goes on behind the scenes for this, so that it runs a lot faster and has more capabilities. Now, the underconstrained bodies command is used typically to understand, hey, what bodies have I not fixed to each other? Because people that have run simulation for a while have commonly gone into, hey, got large displacement errors or something there where a part's flying off in space, and you need to figure out, hey, how is this constrained together, or what fixtures or connections did I miss? However, previously when you ran this underconstrained bodies to do it there, it would have to mesh and then solve your entire study before you would get results. So depending on the size of your analysis, because when you're doing underconstrained bodies, it's generally with assemblies to begin with, then it could take a while where it may not be worth it. You just run it normally and just check your graphs afterwards. But now it uses an algorithm behind the scenes that's called your singular value decomposition. And basically means it's a new method that runs a lot faster to get you the results. Now, one thing to note before I show you it is that this new singular value decomposition within your underconstrained bodies is only available for SOLIDWORKS Simulation Professional licenses and above. So if you have SOLIDWORKS Simulation Standard, or you have SOLIDWORKS CAD Premium, which includes your base level simulation license there, that it will use the old algorithm in that case. But on this one, I mean, it's a decent size assembly. I mean, nothing too crazy, but I'll hit calculate here, and it will process it. And you can see, hey, in just a few seconds that we start getting results. So in this case, it's telling us that something is underconstrained, and it gives us a little animation of what group. So say, hey, these groups of bodies, these three ones are unconstrained in some way. Now, what it gives us in this case may not be intuitive, and I'll exit out of this since we know which group it is. But we have these fixed pins here, these together, or I guess these fixed hinges, and then pins connecting those all together. So everything is connected to one point, but or I guess to one component or another. But in this case, since there's two hinges here that are in here, that they have no rotational stiffness, that hey, this can rotate and this can rotate, so hey, that does add another degree of freedom. So that was able to recognize it in this case. So this is a tool that now I'll recommend that everyone runs it when they're analyzing assemblies, because it's a very quick way to verify your setups. So great tool to be able to use. And again, to get there, just Diagnostic Tools, underconstrained bodies, and you can launch that command for it to run. Alrighty, so the last enhancement I want to talk about for SOLIDWORKS Simulation 2023 is going to be adding virtual linkage rods to nonlinear studies. Now, last year is where they introduced your linkage rod connectors. So what it is, just as a refresher, is that you can add a virtual connector of a linkage rod of your typical rods with that, but it's all virtual, so you don't have to mesh it, but you still get the effects in your assembly. Same reason you would use virtual bolts, which are very commonly used, but in certain circumstances this can be good. But now in the new version, it's allowing us to use this in nonlinear studies. Now, just because it is in nonlinear studies, you do need your simulation premium license in order to use it, but a great new feature to save time there. So I'll go ahead and just add in this case. So we'll say for this link right here is that I'll go ahead and I'll exclude this from the analysis, and I'll manually add one of these linkage connectors. So I'll right-click the connections folder, go to linkage rod, and then it'll be the same setup if you were doing your linear static studies, but what's new is with the nonlinear. So I'll go ahead and I'll select my cylindrical faces of where those connect. I'll go ahead and make sure that they're in the right dialog boxes. Then I'm going to add, in this box, going to be my offset direction, saying off from the center, where is the rod actually connected. So I'm going to change this to centimeters here, so I'll do 0.8 and 0.5, and I can give it its cross section of what's going to be represented. So I'll do a solid rectangle with a width of 1 and a height of 0.5. And I'm going to change this offset so it's there on the back, so you get that effect. Now, just to go through, we right-click on the connections, clicked on the linkage rod, you select the cylindrical face that's connecting to. You can also connect it to individual points or vertices if you change that drop-down option. And this is same for other versions as well that have the linkage rod. But you can choose, hey, is it a pivot joint? Is it a spherical joint that can move more degrees of freedom? Or your rigid joint on one section there. But then that's really the setup of what you do there. Just like with your virtual bolts, you can add in your materials so that you can do a check on this virtual rod after the fact to get some intuition. Hey, actually, is this rod gonna, virtual connector gonna break here? So you need to do more analysis, but that's the main setup there, and so it can be used to save some solve time in what you're doing. So some great new features available in SOLIDWORKS Simulation 2023. We got this contact penalty stiffness option that we talked about that allows us to sacrifice local accuracy in areas of contact in order to get a lot faster solve time and then bring it back when we do our final analysis. We've got our more flexibility in our bonded contacts and be able to do more off-skew faces. We've got diagnostic tools that are available of able to quickly access them, and then finding that underconstrained bodies option, which is great, and then also these virtual rod connectors on nonlinear studies. So hopefully you can start incorporating some of these new items into your everyday work there, but enjoy using simulation, and I hope to talk to you guys at some point.